Every day, billions of messages are sent through apps like WhatsApp, Signal, social media direct messages, and many of these apps claim your messages are protected by something called end-to-end encryption. But what does that actually mean? Can hackers read your messages? Can the company behind the app read them? And if your messages are encrypted, why do privacy experts still recommend some apps over others? So by the end of this video, you'll understand exactly how end-to-end encryption works. Welcome to Tech Trends. Here we break down complex tech topics into simple, practical explanations that anyone can understand. So if you enjoy learning about like AI, cybersecurity, privacy, and the internet, don't forget to hit that subscribe and let's dive in. So, what is encryptions? Let's start with the basics. Imagine writing a letter in a language that only you and your friend understand. If someone steals the letter along that way, they'll see the words, but they won't understand them. That essentially what encryption does. So it takes readable information, something called a plaintext, and transforms it into like a unreadable data, which is called ciphertext. So without the correct key, the information looks like complete nonsense. So basically, encryption protects everything from text messages and emails to online bankings and even shopping. So it's just not limited to messages. When I say the term message, it's like throughout the internet, and it's more should be associated with a form of encryption. So, and there are different types of encryptions as well, but this is the basic of end-to-end encryption, which is also called E2E or E2EE. So you can say E2E encryption as well. However, what's the problem with like those normal messaging without encryptions, right? Think you are sending a message that says, let's meet at 7 p.m. If the messaging service stores or processes that data, right, which is in basically the plain text at this point, anyone with access to the servers can potentially read it. And that would include your employees with privileged accesses, or like this hacker or an attacker who compromises the service, or anyone who gains unauthorized access to that stored data. So this is where end-to-end encryption changes everything. So how does it work? Well, it E2E means a message is encrypted on your device before it leaves your phone. So it travels across the internet as an encrypted data. The messaging company serves simply to deliver this encrypted message. They don't have the key needed to read it. And that is the key point for you to take away is any other provider or anyone through the internet do not have that key. Only the sender and the receiver will have that key. So basically, only the intended recipient device would have the information required to decrypt that message. Even if someone intercepts this data transmission, it appears as meaningless information, as we discussed earlier. So when the message reaches this device, this app uses the correct cryptographic key to convert it back into that readable text. Now, all this happens in a fraction of a second. Most users never even notice it's happening. Like, think of it like sending a locked box. The company transports the box from one place to another, but it doesn't have the key to open it. So only the sender and the recipient can access what's inside. Well, there is one phone which is called the endpoint, and the second phone is also called an endpoint. And these two devices talk between each other through a route called encrypted path, right? So the ends in this end-to-end encryption are nothing but your devices participating in that conversation. So even though in plain English, I would say one end of the device to the another end, but like on a technical test, it's just better to say that it's just like a communication device, right? Because there can be multiple devices at the same time. So let's say if you're in a group chat, every participant device is an endpoint. So there's multiple endpoints, but the receiver would have the key to decrypt the message. And that just goes for like each endpoint of the device. So that's the basic idea behind end-to-end encryption. And well, what does the company sees my message? So an app truly uses E2E encryption for messages. If they do that, then the company cannot read the contents of those messages while they are in the transit, or even if they are stored in an encrypted form on their servers or anywhere like on the cloud or whatever that is, right? So like what does that mean? Like the internet provider can't see it if it's encrypted, and then only these participants can see it. But that doesn't mean the company wouldn't know anything about what's happening, because they may still collect something called as metadata, which is a whole another video in the playlist below, where basically they know that who you contacted, when you sent that message, and then how often you communicate with them, also your device information, and the most classic, your IP address. So metadata doesn't reveal the message itself, but it can still like reveal patterns about your activity. And that's why encryption and privacy are related, but they're not exactly the same thing. So which apps would you use with E2E encryption? Well, several popular messaging apps, I believe, support end-to-end encryption, but they do not all use it in a same way. So, for an example, the Signal app does have end-to-end encryption status by default for all the messages, right? So it's a privacy focused design. Whereas WhatsApp also uses end-to-end encryption, but just for personal chats. And iPhone iMessenger uses end-to-end encryption. Here it says sometime because of the fact that it's only if this is between two Apple devices. So if an iPhone user is sending a message to an Android user, it just basically defaults to a different protocol, which we would say like a mechanism. So it's like using just another app, but here it's just called like a protocol because you're not changing the user interface, but you're using a mechanism of how that uh, message is being like delivered and through what, and depending on like both the devices support. So typically we would use something called as RCS. You must have also seen it on the top of like iPhone's networks, or even on the messages when it converts from iMessage to a regular message. So if both the device and the carriers support it, Apple's Messenger app will support that RCS, and that RCS can be end-to-end encryption. But like I said, it's only in some cases, and that's not done universally. So all I mean to say is that SMS and MMS are used, but they're not end-to-end encrypted at all. So other platforms may offer encrypted conversations like in certain modes or for certain features. So it's always like worth checking what you choose in, like like your app handles encryption the way that it does. Well, so yeah, so that's why. And then, oopsie. Well, using an app with encryption also doesn't mean like that every part of the service is private. So what does it not protect? It was E2E encryption is powerful, but I don't think it's some magic. So if someone unlocks your phone, they can still read your messages. If a malware infects your device, it can capture information before it's encrypted or after it's decrypted. if you back up your chats to a service, that doesn't encrypt them the same way. Again, it's important for a protocol to match a protocol. When there are two protocols or mechanisms, things differ a lot. So Apple to Android, Android to Apple, end to end, or a non-encrypted message. They're all just different things in this way when we speak about it. So nothing should be just automatically assumed just because they all fall sort of into like either protocols or devices in general, right? The communication endpoints. So these are just devices. So if you accidentally send a message to a wrong person, encryption can't undo that. Encryption protects data while it's being transmitted, but it's not used for every possible security risk. There are different things that help to cover those areas, but it's just limited to the transit of the message. So why does it matter? Well, it's for everyone. Your conversations with your family, private pictures, financial informations, or even like medical discussions, or let's say like even work conversations. In a world where there's like so much going on with their lives happening online, protecting personal communication for me just basically feels like a basic part of a digital security, and especially like with the AI tech, so yeah, here are my key points if you're prepping for a test. And if you found this video useful, consider giving it a thumbs up because it does help me assess that you want to see more videos like this, and it also helps the channel grow. So in the next video, we'll explore public versus private keys, which is basically the technology that makes this modern encryption possible. I'll see you guys later.